Welcome everyone. In this video I will talk about eigenvalues and eigenvectors, the concepts and problems related to it. I am uploading video related to matrix topic, so in case if you are new to the channel you can watch the previous videos for better understanding. So let's start. What is the idea related to the eigenvalue and eigenvector? So what it is given, let us look at this and then I will explain through examples also. That let A is a square matrix. So the first observation is A is a square matrix and X is a non-zero vector, and this I am highlighting especially. X is a non-zero vector and lambda is a scalar such that A into X is equal to lambda into X. Then X is called the eigenvector corresponding to the eigenvalue lambda. Now one thing that you need to understand here, that if you look at this system, Ax is equal to lambda x, basically what is happening, that we have a square matrix that we are multiplying it by a vector xy, and in the right hand side we are multiplying that vector xy by just a scalar lambda, and in both the cases we are getting the same result. So this is a very special situation, that on one side you are multiplying the matrix, you are multiplying the vector by this matrix, and on the other side you are multiplying this vector by just a scalar lambda. So this expression Ax is equal to lambda x can also be written as Ax is equal to lambda Ix, because I is the identity matrix. So if you multiply x by identity matrix, it will remain x. You know that property, that I into any matrix is equal to A. So I into x will also remain x, right? Now I can bring this in the left hand side, so you can write one more step, so that you can write Ax minus lambda Ix is equal to 0. Now if you simplify it by taking x common, you will be like getting A minus lambda Ix is equal to 0. Now if you look at this equation 1, it represents what? It represents a homogeneous system of linear equation. Homogeneous system of linear equations. I hope you can visualize that, linear equations. So if we have a homogeneous system of linear equation and I want x to be non-zero, means I want a non-zero solution for this, and in my previous video in detail I have discussed that if we have a homogeneous system like Ax is equal to 0, to get a non-zero solution we need to have determinant of A is equal to 0, means the determinant of the coefficient matrix should be equal to 0. So here the coefficient matrix is A minus lambda I. So for having a non-zero solution of 1, determinant of A minus lambda I should be equal to 0. This is a very important equation which is known as the characteristic equation for any given matrix. Right, just to make sense that this represents a homogeneous system of equation, let me quickly take a small matrix. Suppose I take a small matrix 5 4 1 2, and if I write this, means it is basically what? A minus lambda I. So I will write minus lambda I is 1 0 0 1. So this will become what? This will become 5 minus lambda 4 1, and sorry, this is 1 minus 0, so this will remain in 1, correct, and this is 2 minus lambda, right? So we just subtracted lambda from the main diagonal. I could directly do it, but I was just doing it so that you understand things better. Now this is our A minus lambda I. So if you write A minus lambda I x, means if I multiply this by x here, just to make sense of it, so I take it here 5 minus lambda, I take 4, I take 1, and here I take 2 minus lambda, right? There is something not looking good here, so I just reduce this. Okay, sorry, give me a moment. This, let me rewrite it 2 minus lambda so that it looks better. So 2 minus lambda. So here I multiply it by xy and I'm equating it to 0. So clearly it is a homogeneous system of equation, right? So let me summarize the things before going forward. What I am saying, that given any matrix A, if they will provide us with a matrix A and they will ask us that find that value of lambda such that a times x is equal to lambda times x. This value of lambda will be called as eigenvalue, and this value of x will be known as eigenvector corresponding to this eigenvalue lambda. So what we are going to do, for any given matrix, we first write the characteristic equation, because if you look at the characteristic equation, this is how it looks like, and once we write the characteristic equation, then we find the solution of it to get the values of lambda. So let us solve some problem to understand it better. So first question is that find the characteristic equation of this matrix. So let me call this matrix A. So what is the characteristic equation of this matrix? The characteristic equation is A minus lambda I, and its determinant is equal to 0. So if I have to evaluate the determinant, I will write 5 minus lambda, and I hope it is clear to you from this explanation that if you write A minus lambda I, basically you just subtract lambda from the main diagonal. So here I am just subtracting lambda from the main diagonal, and here I will have 1, and here I will have 2 minus lambda is equal to 0. So if you simplify it, you just expand the determinant. 5 minus lambda into 2 minus lambda minus 4 is equal to 0. So further simplification will help us. So 5 into 2, 10, minus 2 lambda minus 5 lambda plus lambda square minus 4 is equal to 0. And as the convention is that we write the highest degree term first, so I write lambda square, then minus 2 lambda and minus 5 lambda is minus 7 lambda plus 6 is equal to 0. So this equation that I have got is known as the characteristic equation of this matrix. So few observations related to the characteristic equation, that if the matrix A is of size 2 cross 2, or we can say of order 2, then characteristic equation will be a polynomial of degree 2, right? So the characteristic equation, like here it is lambda square, so we are getting an equation of degree 2. Similarly, if I take a matrix of size n cross n, this characteristic equation, the left hand side will be a polynomial in degree n. Now before I proceed further, I want to highlight few things, that there is a shortcut method also of writing the characteristic equation. So there is alternate method, right? So let me tell you what is the alternate method. So it will be very useful for you to write the characteristic equation directly, and this method is for a 2 cross 2 matrix. So what we do, we write the characteristic equation, we write lambda square minus trace of the matrix given, trace of A times lambda, and plus determinant of A is equal to 0. Trace of a matrix is defined as, trace is of A is defined as sum of the diagonal elements, right? So this is how you define the trace of a matrix. So if I have to write the characteristic equation of this, I will write lambda square minus, what is the trace of A? The diagonal elements are 5 and 2, so sum is 5 plus 2 times lambda, and plus determinant of A. So if I calculate the determinant of A, I will get 5 into 2 minus 4 into 1, so that is 10 minus 4 is equal to 6. So I get 6 is equal to 0. So what did I get? I get lambda square minus 7 lambda plus 6 is equal to 0. So this is same as this equation. So we can also use this to write the characteristic equation of a 2 cross 2 matrix. Okay, now let us proceed further. Now what is the characteristic root or eigenvalue? So as we know that the moment we have got the characteristic equation, we can solve the characteristic equation to get the values of lambda. So you can see that the roots of the characteristic equation are said to be the characteristic root or eigenvalue of the matrix, right? Now how to find the characteristic root of this matrix. To solve it, first of all I will write its characteristic equation. So since I already have got the characteristic equation here, lambda square minus 7 lambda plus 6, I am not going to put extra effort, so I am writing the characteristic equation as lambda square minus 7 lambda plus 6 is equal to 0. Now to get the lambda value, I need to factorize it, so I will write lambda square minus 6 lambda minus lambda plus 6 is equal to 0. From the first two terms I can take lambda common. I will get lambda minus 6 minus 1 lambda minus 6 is equal to 0. So I will get what, ladies and gentlemen? I will get lambda minus 6 into lambda minus 1 is equal to 0. So I got lambda is equal to 6 and 1, right? So we have got the eigenvalues, that is 6 and 1. So these eigenvalues are the eigenvalues of this matrix. So by now I am clear about two things. One is how to write the characteristic equation. Characteristic equation in general is written as determinant of a minus lambda I is equal to 0. Then we solve this equation to get its roots, and the roots are known as the characteristic roots or eigenvalues. There are few observations here which I want to highlight. One thing, that there is a very interesting property, and I will be discussing about the properties of eigenvalue and eigenvector in detail in my next video. But because this is important to observe here for evaluating or checking whether the eigenvalues that we are getting are correct or not. So the first observation is that if you take the trace of A, what you get here is 5 plus 2, that is equal to 7. And here if you take the sum of eigenvalues, sum of eigenvalue is 6 plus 1 is equal to 7. So there is an interesting characteristic that trace of a matrix should be equal to the sum of eigenvalues. So you saw that 6 plus 1 is 7 and the trace is also 7. Another interesting observation I want you to make, that if you find the product of eigenvalue, so what is the product of eigenvalue? Product of eigenvalues is equal to, here 6 into 1 is 6. And if you calculate the determinant of this matrix, if I ask you calculate the determinant of a 5 into 2 minus 5 into 2 10 minus 1 into 4 4 is equal to 6, right? So it means what, that the product of the eigenvalue is equal to the determinant of the matrix. You can write it, and sum of the eigenvalue is equal to the trace of the matrix. So this thing helps us to check whether the values that we have got are right or not. Proceeding further, I am going to find the eigenvectors of this matrix. So we already know how to find the characteristic equation and how to find the characteristic root or eigenvalue. Next thing that we are going to do is to find the eigenvector. So basically if you remember what I discussed, actually I was trying to solve the system of equation a minus lambda I x is equal to 0. I just want to show you one more time. This was the equation number 1, right? A minus lambda I x is equal to 0, and my aim was to solve it so that we get x as a non-zero vector. So that is why we have equated determinant of a minus lambda I is equal to 0, right? So if I have to get the eigenvector, basically what we need to do, so I am going to write the detail, and just listen carefully. So to get the eigenvector, first of all you have to write the characteristic equation of this matrix. Since we already have done that, so I am not going to repeat the whole thing. So characteristic equation of this matrix is lambda square minus 7 lambda plus 6 is equal to 0, which we already have got here in this part, right? Now the next thing is to find the eigenvalues. So eigenvalue also I have got in this part, that is lambda is equal to 6 and 1. So I write without much discussion that lambda is equal to 6 and 1. But when you will be solving it as a problem, you have to write all the details, like how to write the characteristic equation and then how to get the eigenvalues. My aim is to get the eigenvector. So first of all I take these two eigenvalues one by one. So I take lambda is equal to 6 first. So if you take lambda is equal to 6, and this was your equation which you wanted to solve, And since you already have got this characteristic equation, how did you get this? By equating determinant of a minus lambda is equal to 0. So you are already aware, and this is important, I am highlighting it, so be careful. Determinant of a minus lambda I already have equated to 0, so I know for sure that this will have a non-zero solution if I take lambda is equal to 6, because if I take lambda is equal to 6, this determinant will become 0. So for lambda is equal to 6, we have this system that is a minus 6i x is equal to 0. So basically what does this represent? I have to subtract 6i from a, means I need to subtract 6 from the main diagonal, right? I hope you understand. If I say subtract 6 times I, means 1 0 0 1. So basically what it will be, 5 minus 6 means, and 2 minus 6 means you need to subtract 6 from the main diagonal. So it will become 5 minus 6 is equal to minus 1, 4 and 1, and 2 minus 6 is minus 4, and we are solving it to get the vector xy, so this is equal to 0. Yes, so now this is a homogeneous system of equation, and we know how to solve the homogeneous system of equation. So to solve it, we have to reduce the homogeneous system into echelon form. Okay, so to reduce it in the echelon form, what we need to do, we need to perform an elementary operation like r2 goes to r2 plus r1. So what I will get, I will get minus 1 4 1 sorry, if I add it I will get 0 and I will get 0. So 0 0 and then xy is equal to 0. Now the rank of this matrix is 1 and there are two variables, so here I am writing in this side that I'm continuing. So we are getting a system that is minus x plus 4y is equal to 0. Okay, now ladies and gentlemen, one thing that there is actually two variable and one equation, and this is the pivot element. If it is not making sense, you need to watch the previous video. So this is the pivot element, and the variable, the arbitrary value that I have to assign is to the variable y. So this is a standard practice that we take the least value or smallest value so that the computation is easier. So what I am going to do, I am going to take y is equal to 1. So if I take y is equal to 1, I will get x is equal to 4. Yes or no? So I have got a vector xy which is equal to 4 1, right? So this vector is known as the eigenvector corresponding to the eigenvalue, that is lambda is equal to 6. Now some of you may argue that why you have taken y is equal to 1. I could have taken y is equal to anything. In general, I can take y is equal to c also. C may be any value, any real number. So if I take y is equal to c, I will get x is equal to 4c. So I will get the eigenvector like 4cc, which is nothing but c times 4 comma 4 1, right? So it means what, that if I have got 4 1 as the eigenvector, any multiple of 4 1 will also be an eigenvector. So if I can write 8 2, this is also an eigenvector. I can write minus 4 minus 1, this is also an eigenvector, right? So usually we take the eigenvector as the smallest kind of means with a smallest kind of entry, so that the computation remains easier or manageable. But as a concept, you should be clear that any value of y could have been taken. In general, I can take c. So what I get is something like c times 4 comma 1. So this is an eigenvector, right? So proceeding further, I have got the eigenvector corresponding to lambda is equal to 6. Now I need to get the eigenvector corresponding to lambda is equal to 1. So here I am continuing. I have the value lambda is equal to 1. I have the matrix that is 5 4 1 2. So we need to solve the system that is a minus lambda I x is equal to 0. So a minus lambda I x in this case will be what? It is just a minus I x is equal to 0. Means we just have to subtract 1 from the main diagonal. So this will become 4 4 1 1, and to get the vector I am taking the vector x y is equal to 0. To reduce it to echelon form, we can perform the elementary operation. What elementary operation? We can perform you know, R2 goes to R2 minus 1 by 4 times R1. So this will give me 4 4 0 0, and here I will get xy is equal to 0. So the equation corresponding to this is 4x plus 4y is equal to 0, and I was aware that I will get a 0 row, because it is sure that I will get a non-zero solution. So 4x plus 4y, and here 4 is the pivot element, so again I have to select the y variable as the free variable. So suppose I take y is equal to 1, so in this case we get x is equal to minus 1. So we have got the eigenvector like minus 1 and 1. And again I repeat this argument that I could have taken the y value to be any arbitrary value. So suppose I take y is equal to c, then I will get x is equal to minus c. So the eigenvector in this case will be minus c c. So I can take c common, and minus 1 1. So basically any eigenvector is just a multiple of this eigenvector. Okay. So this is the concept related to eigenvalue and eigenvector, where we have talked about that how to calculate the characteristic equation of a matrix, how to get the eigenvalues, and then how to get the corresponding eigenvectors. Okay. So before I proceed further, I just want to show you that for lambda is equal to 6, I have got this eigenvector. For lambda is equal to 1, I have got this eigenvector. And basically our aim was, for given matrix A, this was the matrix A, I wanted to get x and lambda such that ax is equal to lambda x. So you can verify that also. Suppose you take the matrix that is 5 4 1 2, and if you multiply it by this x, that is 4 1, right, then how much you will get? You will get 5 into 4 20 plus 4, that is 24, and 4 into 1 4 plus 2, that is equal to 6, right, which is nothing but lambda value, that is 6 times the eigenvector, that is 4 1. So you realize this, the thing that I wanted, that I have got a vector x, and this vector x, if I am multiplying it by a matrix here or by a scalar, in both cases we are going to get the same value. The same thing you can verify for this value of lambda and its corresponding eigenvector as well. Okay. So proceeding further, I am going to take a 3 cross 3 matrix and illustrate the whole thing in detail. So the problem here is the complete question: find the eigenvalue and eigenvectors of this matrix. Let me call this matrix A. I am going to do the detailed solution here. So first of all, what is the characteristic equation? I am writing the characteristic equation is given by determinant of A minus lambda I is equal to 0. So to evaluate this, I need to subtract lambda from the main diagonal. So I will get 1 minus lambda, 1, 3, 1, 5 minus lambda, 1, 3, 1, 1 minus lambda equal to 0. Now I have to expand this. So to expand this, I am going to expand it about the first row. So 1 minus lambda into 5 minus lambda, 1 minus lambda, this into this, minus 1, then minus 1, 1 into 1 minus lambda, that is 1 minus lambda, and 3 into 1, so minus 3, and then plus 3, 1 into 1 is 1, minus 3 into 5 minus lambda is equal to 0. Okay, up to this I hope it is clear. So proceeding further, I am going to simplify it. So 1 minus lambda, and if I multiply it 1, so I will get 5 minus lambda, and then by minus lambda, so I will get minus 5 lambda plus lambda square minus 1, right, then minus 1, 1 minus lambda minus 3, and then plus 3, 1 minus 15 plus 3 lambda is equal to 0. So let us do it further. 1 minus lambda, and here it is lambda square, and minus 6 lambda, and 5 minus 1 is equal to 4. Here I get minus 1, minus lambda, and 1 minus 3 is minus 2, and here I get 3 minus 14 plus 3 lambda is equal to 0. So now multiply this 1. So by 1 I will get lambda square minus 6 lambda plus 4. By minus lambda I will get lambda cube plus 6 lambda square minus 4 lambda. Then I will get plus lambda and plus 2, and here I will get minus 42 minus 9 lambda is equal to 0. So simplifying it will give me what? Minus lambda cube. So I write minus lambda cube. Then lambda square plus 6 lambda square, right? So I will get plus 7 lambda square. Now minus 6 lambda and minus 4 lambda, that is minus 10 lambda, and here we have lambda plus 2. So here we have lambda, and here I think it is not minus 9 lambda, 3 into 3 lambda, it is plus 9 lambda, so be careful. So here we have lambda and 9 lambda, so it is 10 lambda and minus 10 lambda, so it will cancel minus 6 minus 4 minus 10, and lambda plus 9 lambda 10 lambda, so it will cancel. And here you have 4 plus 2 6, this term and this term 6 and minus 42, so I will get minus 36 is equal to 0. So I can write it better by taking minus common. I can write lambda cube minus 7 lambda square plus 36 is equal to 0. So this is a cubic equation because it was a matrix of size 3 cross 3. So if a matrix is of size 3 cross 3, the characteristic equation will be a cubic equation. Now we need to factorize it to get the value of lambda. So I am continuing here on the next page. So we have got the characteristic equation, that is lambda cube minus 7 lambda square plus 36 is equal to 0. Now how to factorize this, and this is a challenging thing for a lot of students, but we are going to use the hit and trial method. And how the hit and trial method will work, that if I take lambda is equal to minus 2, I will get what? I will get minus 2 cube, that is minus 8, minus 7 into minus 2 square means 7 into 4, that is minus 28, plus 36 is equal to 0. Okay, so it means that we have lambda plus 2, because lambda is equal to minus 2 is a root of this equation, means lambda plus 2 is a factor, right? There is a theorem which you have studied in a school as factor theorem. So lambda plus 2 will be a factor of this. Now I know that one of the root is minus 2. Since it is a cubic equation, we have to get 3 roots. So I need to factorize it further. So I write lambda square into lambda plus 2. I hope you know how to factorize. And now it is lambda cube plus 2 lambda square. So and I want minus 7 lambda square. So I write minus 9 lambda into lambda plus 2. So minus 9 lambda square and plus 2 lambda square will give me minus 7 lambda square and minus 18 lambda. So I need to write plus 18 lambda plus 2 is equal to 0. So what did I get? I get lambda plus 2 into lambda square minus 9 lambda plus 18 is equal to 0, which I can factorize further. So I will get lambda plus 2, and to factorize it I will write lambda square minus 6 lambda minus 3 lambda plus 18 is equal to 0. So I do this thing, I write lambda plus 2 and then I take lambda common, so I get lambda minus 6 minus 3 common, I get lambda minus 6 is equal to 0. So I got it lambda plus 2 into lambda minus 6 into lambda minus 3 is equal to 0. So I got lambda value, that is minus 2, 6 and 3. Now some of you might have got it slightly difficult to factorize it. So in case if you find it challenging to factorize it further after getting a factor, you can do the division also. Like you can take lambda cube minus 7 lambda square plus 36 and you can divide it by lambda plus 2. So if you do it, you will get lambda square here, means you will get lambda cube plus 2 lambda square, right? See, I mean since I am explaining, I am doing multiple ways, but as a student you have to do the way you are feeling comfortable. So I take minus minus, this cancel, I get minus 9 lambda square plus 36. So I am writing minus 9 lambda, and I will get minus 9 lambda square minus 18 lambda, right? So it will become plus, it will become plus. So this and this cancel, you will get 18 lambda plus 36. So if you take plus 9 here, or not plus 9, you want 18 lambda, so you have to take plus 18, right? So you want 18 lambda plus 36, and when you subtract, this will be minus minus, so it will become 0. So you got lambda cube minus 7 lambda square plus 36 is equal to lambda plus 2 into lambda square minus 9 lambda plus 18. So this is what I have got here also directly. So it is up to you that how do you factorize, right? So the next thing that we are going to do is to verify that whether this eigenvalues that I have got are right or not. So the given matrix is this. So if I ask you what is the trace of this matrix, so trace here is equal to diagonal element 1 plus 5 plus 1, that is 7. And if I ask you what is the sum of eigenvalues, so if you take their sum, minus 2 plus 6 plus 3, so 9 minus 2 is 7, means it is verified that the eigenvalues that I have calculated are correct. Now the next thing that we are going to do, I am going to find the eigenvalues corresponding to each of the eigenvectors. So the first thing is lambda is equal to minus 2. So we have the system, let me write the matrix here for our convenience. We have the matrix 1 1 3 and 1 5 1 and 3 1 1, right? This is the matrix given. Now for lambda is equal to minus 2, actually what we have to do to get the eigenvector, we have to solve this system a minus lambda I x is equal to 0. So for lambda is equal to minus 2, this will be a plus 2i, means I have to add 2 to the main diagonal. So I will get 1 plus 2 is 3 1 3, then 1 5 plus 2. So what is 5 plus 2? 7, right? 3 1 3 1 7 1, and then 3 1 and 3, okay? And then we need to multiply it by x y z is equal to 0. So if I simplify it, what operations I have to perform to make it 0 and to make it 0? So to make R2 element 0, I will write R2 goes to R2 minus 1 by 3 times R1, and to make this 0, I will write R3 goes to R3 minus R1. So I get a system 3 1 3, this will become 0 0, actually this will be all become 0, and here 7 minus 1 by 3, so 21 minus 1, that is 20 by 3, and here I have 1 minus 1 by 3, so that is also equal to 0, right? And we have this x y z is equal to 0. Now this is in echelon form. The rank here is 2 and the number of variables are 3, which I was aware that I will get, but just to highlight this. So we are getting the system like 3x plus y plus 3z is equal to 0, and the second one is giving me 20 by 3y is equal to 0. So this will clearly give me y is equal to 0, right? Now as you can see, we have a pivot in the x column, pivot in the y column, but we don't have any pivot in the z column. So I have to select z variable as the free variable, right? Which variable I have to select? Z variable as the free. So I can take z is equal to 1, right? I can take any arbitrary value, but as I told you in the previous problem also, that I take the smaller or simpler values like 1 0, so that the things are easier. So I take z is equal to 1 and y is equal to 0. So if I take z is equal to 1, it will become 3. So x I will get also equal to minus 1. So we have got the eigenvector, that is minus 1 0 and 1, and any multiple of this will also be an eigenvector. Like if I take z is equal to 2, then I will get some other eigenvector, or if I take any c also, I will get minus c 0 and c. So this is how the eigenvector will look like. But in general, a standard practice is that we take zeros and ones so that we get simpler looking eigenvectors. So the first eigenvector is -1, 0 and 1, corresponding to lambda is equal to -2. I will also solve it for lambda is equal to 6 and 3. So let's proceed further. So for lambda is equal to 3, I need to solve the system that is a minus lambda I x is equal to 0. So this will be basically a minus 3i x is equal to 0. Means I have to subtract 3 from the main diagonal. So if I subtract 3 from the main diagonal, 1 minus 3 is -2, 1, 3, 1, 5 minus 3 is 2 and 1, and this is 3, 1, and 1 minus 3 is -2, right? X, y, z is equal to 0. I hope it is clear up to this. Only thing that will change is this is 1, 3, 1, this is 1, 3, 1, and I have subtracted 3 from the main diagonal. So 1 minus 3 is -2, 5 minus 3 is 2, and 1 minus 3 is -2. Now what I have to do, I have to make this 0 and this 0. So for that I have to perform the operation. So I am writing here, this implies I am performing the operation. R2 goes to R2 plus 1 by 2 times R1, because if I multiply it by 1 by 2 it will become -1, and R3 goes to R3 and how should I get 3? So if I multiply it by 3 by 2, right, 3 by 2 R1. So I will get -2, 1, 3, 0, 0, and 2 plus 1 by 2. So 2 plus 1 by 2 is 5 by 2, and 1 plus 3 by 2. So 1 plus 3 by 2 is also 5 by 2, right? And here it is 0, and 1 plus 3 by 2 is 5 by 2, and -2 and 3 into 3, 9 by 2. So -2 plus 9 by 2 is 5 by 2, right? So this is what we got. X, y, z is equal to 0. So we need to perform one more operation, like for on this matrix I will write R3 goes to R3 minus R2. Some of you might have seen a direct approach that they take two equations and then they reduce it. I believe that that is not algorithmic, so I'm doing the hard way. So -2, 1, 3, and this is 0, 5 by 2, 5 by 2, and 0, 0, 0, and it is multiplied by x, y, z, that is equal to 0. So this gives me what? This gives me -2x plus y plus 3z is equal to 0, and it gives me 5 by 2y plus 5 by 2z is equal to 0. So I can take z is equal to 1. So if I take z is equal to 1, I will get y is equal to -1, and what will be the x in that case by back substitution? So -2x plus y means -1 plus 3z means plus 3 is equal to 0. So we got -2x plus 2 is equal to 0. So we got x is equal to 1. So the eigenvector that I got corresponding to this is x is 1, y is -1, and z is equal to 1. I hope up to this it is clear. Next I am going to calculate the eigenvector corresponding to lambda is equal to 6. So here I have to write a minus lambda I x is equal to 0. So basically this is a minus 6i x is equal to 0. So we have to subtract 6 from the main diagonal. So 1 minus 6 minus 5, 1, 3, 1, 5 minus 6 is -1 and 1, and 3, 1, and 1 minus 6 is -5, right? Now I have to reduce it to the row reduced echelon form is equal to 0. So I hope it is correct. 1, 3, 1, 1, 3, 1, and 6. So it will be -1, it will be -5 and -5. So I have to make this 0, this 0. It may look difficult for you, but still we are going to follow the algorithm. So -5, 1, 3, I have to make this 0 and 0. How to do that? To do that I have to actually on this I have to perform R2 goes to R2 plus 1 by 5 times R1, and R3 goes to R3 plus 3 by 5 times R1. So minus 1 and plus 1 by 5, minus 1 plus 1 by 5, so it is minus 4 by 5, and 1 plus 3 by 5, so it is 8 by 5, and 1 and plus 3 by 5 is 8 by 5, and minus 5 and plus 9 by 5, so minus 5 plus 9 by 5, so it is how much? Minus 16 plus 9, minus 25 plus 9 is 16, minus 16 by 5. Be careful in the calculation. So x, y, z is equal to 0. On this, let me write it better. This is 8 by 5. So you can clearly see that I can make this 0. So on this I am performing the operation R3 goes to R3 and plus 2 times R2. So if I do this, I will get minus 5, 1, 3, 0, minus 4 by 5, 8 by 5, 0, 0, 0, and here we have x, y, z is equal to 0. So we have the equation like minus 5x plus 4y plus 3z is equal to 0, and minus 4 by 5y plus 8 by 5z is equal to 0. Z is the free variable here, so I will take z is equal to 1. So if I take z is equal to 1, if I substitute it, minus 4 by y, let me write here, minus 4 by 5y is equal to minus 8 by 5, so y is equal to 2, and if I substitute y is equal to 2 here, I will get minus 5x plus 4 into 2, 8 plus 3, so 8 plus 3 is equal to y I have got 2 and z I have 1, so minus 5x plus y plus z, so minus 5x plus y 4y, so 4 into 2 8 plus 3 11 is equal to 0. So x is equal to minus 11 by minus 5 means 11 by 5, so I get x is equal to 11 by 5. Okay, I think here I made a small mistake because I was just looking at this. This mistake that I have made when I am writing this minus 5x plus y, not 4y, so that is why I was getting a very different kind of thing. So it is just y, so minus 5x plus y plus 3z, and this is minus 4 by 5y plus 8 by j. So this x value that I have got, I need to correct it. So what is the x thing that I will get here? Just sorry for this. So I am going to rewrite it. So I have minus 5x plus y, so I have got 2, and z I have got 1, so 3, so is equal to 0. So minus 5x is equal to plus 5 is equal to 0, so x is also equal to 1. So I got x is equal to 1 here in this case. Okay, so the eigenvector corresponding to this I got 1, 2 and 1. So I have solved this question completely. It has taken me some time, but I hope you have understood the things better. So given there was a matrix, first of all I have to write its characteristic equation, then I have to factorize it to get the characteristic root, and then corresponding to each of the characteristic roots I have to solve them to get the characteristic so eigenvectors. So I hope it is clear. Now there is one more thing that I want to talk about, and the thing that I want to talk about, that I just want to write the characteristic equation in a different way. And here the characteristic equation is lambda cube minus 7 lambda square plus 36, but I can write it in an alternate way also. So let's discuss that as well. So we have this matrix A, and for this is the characteristic equation we have got by the regular method. What is the alternate method when we have a 3 cross 3 matrix, right? Alternate method. For 2 cross 2 we already have seen. For 3 cross 3 the characteristic equation will be given by lambda cube minus trace of the matrix trace of matrix A times lambda square uh, plus, and this is important, sum of minors along the main diagonal, sum of minors along the main diagonals time lambda minus determinant of A is equal to 0. It is easy to remember, plus minus plus minus. So if I ask you what is trace of A, trace of A is very clear, that is 1 plus 5 plus 1, that is equal to 7. Okay. Next thing that I need to calculate is sum of minors along the main diagonal. So along the main diagonal there are three elements, 1, 5, 1. So if I ask you what is the minor of 1, which I can call M11, because minor of 1 element. So to calculate the minor, I need to leave this row and this column. So 5 into 1, I write it 5 into 1 minus 1 into 1. So 5 minus 1 is equal to 4. If I calculate the minor of element 5, so what will be M22, minor of element 5? I have to leave this row and I have to leave this column. So 1 into 1 is 1, minus 3 into 3 is 9, that is minus 8. And if I ask you what is the minor of the third element, M33, so I have to leave this row and this column. So 1 into 5, so 1 into 5 minus 1 into 1. So 5 minus 1 is equal to 4. So sum of minor along main diagonal means if I calculate M11 plus M22 plus M33, this is equal to how much? 4 minus 8 plus 4 is equal to 0. And if I calculate the determinant of A, what I will get? 1, I am expanding it about the first row, so 1 into 5 minus 1 minus 1 into 1 minus 3 and plus 3 into 1 minus 15. So I get how much? I get 4, and this is minus 2, so minus 2, so it will become plus 2, and it is minus 14 into 3, so minus 42. So what I get is minus 36. So now I put all these values. Here. So of what I will get? I will get lambda cube minus, now trace is 7, so I will get minus 7 lambda square, and sum of this is equal to 0. So there is no lambda term because I will get plus 0 times lambda, and minus determinant of A. So determinant I got minus 36, so minus minus plus 36 is equal to 0, which is nothing but lambda cube minus 7 lambda square plus 36 is equal to 0. This is the same as the characteristic equation we have got through the regular process. I hope everything is clear up to this. So before I end this, I want to discuss one very important thing, and for this I have taken this a specific problem, but I am not going to spend too much time on this because I want to discuss one concept. Rest of the things I think is already clear to you. So I am not going to find eigenvalue and eigenvector. I am just writing the things which I have already done, and you can verify whether it is correct or not. So its characteristic equation will be given by lambda cube plus lambda square minus 21 lambda minus 45 is equal to 0, and its characteristic roots will be given by 5 minus 3 and minus 3, right? You can verify it is minus 6 plus 5 minus 1, and it is also trace is also minus 1. I want to calculate for lambda is equal to minus 3. I want to calculate the eigenvector. So how do you calculate the eigenvector? You take A plus A minus lambda I. So here I take A minus lambda I. So A minus lambda I x is equal to 0. In this case lambda is minus 3, so I will get A plus 3I x is equal to 0. So basically what I am going to do, I am going to add 3 along the main diagonal of this matrix. So if I add 3, I will get 1, 2, minus 3, and here I will get 2, 1, not 1, 1 plus 3, so 2, 4, and minus 6, and then minus 1, minus 2, and 0 plus 3 is equal to 3. And here we have the eigenvector x, y, z is equal to 0. Now I have to reduce this. So to reduce this, and this is why we need to follow the process, otherwise what will happen if we directly take it, we will not get the idea. So to make it 0, I have to replace R2 by R2 minus 2 times R1 and R3 by R3 plus R1. So what I will get? I will get 1, 2, minus 3, 0, 0, 0, 0, 0, 0. Everything will become 0. You can clearly see this is twice of the first row. 1, 2, 3, 2, 4, minus 6. This is just minus 1 times this row. So minus 1, minus 2, and 3. So we have just one equation, and its rank is 1. So we have just one equation here. The rest of the two rows became 0. So if I write it, I will get x plus 2y minus 3z is equal to 0. So the thing that I wanted to highlight here is that now we have just one equation, 3 variable, and we have pivot element in x column. So we have to select y and z column, or y or z variable as the independent variable. So the standard practice here is that I will select first, in first case I will select y is equal to 1 and z is equal to 0. Don't select both y and z 0, otherwise you will get x also 0 and you will get a 0 vector, which we don't want. Eigenvectors are non-zero vector. So if I select y is equal to 1 and z is equal to 0, what I will get? I will get x is equal to, this will become 0, so x plus 2, so x is equal to minus 2. So we got a vector that is minus 2 and y1 and z0. But there is another possibility. I can also select y is equal to 0 and z is equal to 1. So in that case, what will be the x? If I take y is equal to 0, this will become 0, and z, so x will be equal to 3. So I have got an eigenvector that is 3, and y is equal to 0 and z is equal to 1. Now these two vectors that I have got are independent vectors. Like in the previous case, I was explaining this point earlier. I hope you remember, somewhere it must be there, that I can take any multiple of this. Like here I explained that if I got an eigenvector minus 1, 1, then I can take any multiple of this as an eigenvector. But the point I want to highlight here, again I repeat it, that for the same eigenvalue, that is lambda is equal to minus 3, we are getting two independent eigenvector. It means what? That if you take minus 2, 1 and 0, this vector, that is 3, 0, 1, is not possible to be generated with the help of this, because if you take any multiple of this vector, it will always have a 0 here, but you have 0, you have a non-zero element, means these two are independent vector, means this vector can't be written, this vector cannot be written as some multiple times the other vector, that is 3, 0, 1, right? Similarly, this vector also can't be written as some multiple times the other vector minus 2, 1, 0. So it means what? That for an eigenvalue lambda is equal to minus 3, we are not just getting one independent vector, but we are getting two independent vector. And there is a concept that any combination of these two vectors will also be an eigenvector. So I can say, suppose I say this vector as vector v1 and this vector as vector v2. So if I take any combination like c1 v1 plus c2 v2, that will also be an eigenvector of this. So this is something that I wanted to highlight. So we have already discussed all the related concept, and the video is already like quite long. But you must have realized that if you want to discuss something in detail and very systematic way, the videos become longer, but that is not a problem. We can certainly spend some time watching that. So this is all about eigenvalues and eigenvector. What is characteristic equation, what is eigenvalue, what is eigenvector, what is linearly independent eigenvector, and how to get all those things. So this is all for the video. In the next video I'll be talking about the properties of eigenvalues and eigenvector, and then there are few topics that I want to discuss in the next videos, or maybe the other video that I'll be creating. One is Cayley-Hamilton theorem, and another is finding the inverse of a matrix using the Gauss-Jordan method. So that's all for this video. Thanks for watching. Do share it with all your friends so that they also get benefited. Thank you.